Good day, everybody. How are you doing all? Today we are going to discuss about solving for n terms in an annuity equation. So let me share my screen with you. The present value P of an annuity with payment size R, periodic rate I, and a term of n payments is given by the formula is P times 1 plus I to the power of n is equal to R times 1 plus I exponent n minus 1 divided by I. And the question is solve this equation for n. So solution. Actually, I have written this equation a little bit different. So from what is actually the equation. So first I'll correct that. This is the R is inside or outside the parenthesis. As it is written, it's looking R is inside. So this is equal to R multiplied by 1 plus I to the power of n minus 1 divided by I. And R is outside. R is the payment of size R. I is the interest rate, periodic interest rate, and n is the number of payments, P is the present value. So we have to solve for n. So let's do the solution now. So solution, we know P, this is given to us, I to the power of n is equal to R 1 plus I to the power of n minus 1 divided by I. First thing we will do is multiply by I on both sides. N is equal to R times 1 plus I to the power of n minus 1. The whole thing is divided by I, and we multiplied by I also. So this I and this I will cancel. Now we will divide by I on divide by R on both sides. So what will happen now is I times P 1 plus I to the power of n, that will be divided by R, and R divided by R on the right hand side of the equal to sign is 1 plus I, whole thing n minus 1. So this R and this R will cancel. So if I create some space for myself, okay. So basically I have on the left hand side of the equation I times P by R times 1 plus I to the power of n is equal to 1 plus I to the power of n minus 1. Now I multiplied by P divided by R is a constant, is equal to, let's call it A, is equal to constant. Why it is constant? Because its value will depend on the given value of I, given value of P, and given value of R. So it is not going to fluctuate. So we can write the left hand side is A times 1 plus I to the power of n is equal to right hand side 1 plus I to the power of n minus 1. Okay. Now so what I will do now is I will add 1 on both sides. Okay. So, but before I do that, let me create some space for myself. So this will be A 1 plus, this is plus 1 plus I to the power of n is equal to 1 plus I to the power of n minus 1. I will add plus 1 on this side, plus 1 on this side. So this and this will cancel. So I will have a to the power of 1 plus I to the power of n is equal to 1 plus I to the power of n. And I forgot the plus 1 on this side. Okay. Now I will subtract a to the power of 1 plus I to the power of n on both sides. So what do I have finally? I have 1 is equal to 1 plus I to the power of n minus a times 1 plus I to the power of n. Okay, let me create some more space for myself. Now on the right hand side of the equation, I can take 1 plus I to the power of n as a common term, and inside the parentheses I will have 1 minus a. Okay, so if I take the natural logarithm of both sides, ln1 is equal to ln of the right hand side, which is 1 plus I to the power of n times 1 minus a. Okay, now ln1 is 0. So 0 is equal to ln, and then I'll use the product rule of logarithm. So it is ln1 plus I exponent n plus ln1 minus a. Okay, now creating some more space. Okay, so 0 is equal to, using the exponent rule of logarithm, is n times ln 1 plus I to the power of n plus ln 1 minus a. Okay, so if I subtract minus ln 1 minus a on both sides, on the right hand side ln 1 minus a cancels, so I have minus ln 1 minus a is equal to this. I'm sorry, this should not be any exponent anymore because I took the n in front, is equal to n times ln 1 plus I. Okay, so now what will I do? Let's create some space again. I will divide by ln 1 plus I on both sides. 1 plus I. Okay. So basically I have minus ln 1 minus a divided by ln 1 plus I is equal to n. So I have found the solution, but I have to plug in the values. So therefore n is equal to minus ln 1 minus a can be written as ln of 1 minus a to the power of minus 1 divided by ln 1 plus I. Okay, so this can be written as ln 1 over 1 minus a divided by ln 1 plus I. Now I will substitute the value of a. Okay, remember a is a constant, so let me take a look at what a actually is. So if you remember, a is I times p divided by r. I times p divided by r. So here I can write, so let me move this. Okay, before I move it, please. Okay, so ln 1 over 1 minus for A I times P over R divided by ln 1 plus I. So this can be simplified into ln 1 over, I can write this as R over R minus IP over R, right? So 1 is written as R divided by R, the whole thing big parenthesis, okay? And then divided by ln 1 plus I. So this is simplifying to n is equal to, then equal to ln in parenthesis, the R in the denominator will come in the numerator, divided by R minus IP divided by ln 1 plus I. So this is your final solution. This is your answer. So basically bunch of algebra simplification. I'll stop here today. If you have any question, comment, write me a note. I'll get back to you as soon as possible. If you like this video, please share with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button at the bottom right corner. I'll see you next time with another interesting problem and interesting solution. Take care. Thanks for watching. Have a nice day. See you next time.